Okay, so this is a review before you take the Module 7 test. It's going to allow you to consolidate some really important skills, Module 7 based skills for succeeding in this test. So please take it very, very seriously. So I'm going to do this by reference to simply just one problem, and it's one that you haven't seen before, but it's a quite simple problem. The problem is take P or P, a disjunction, as an assumption, and prove that if not P, then S. Now this would be quite a legitimate problem to have you do, because it's completely provable using the methods of the previous modules, but it is also admittedly a very strange looking problem. P or P is an odd thing to assert. Now you know the only way that P or P could be true is if P is true, right? Because the disjunction is the kind of proposition that is true only if one, or at least one of the disjuncts is true, and in this case, the disjuncts are the same proposition. So if you thought through this a little bit and realized that P or P simply implies P, then the conditional, the conclusion, if not P, then S, is really taking advantage of what we've learned in discussing negation introduction, right? If you know that P, then if you were to hypothesize that not P, you'd have P and not P, and that would be a contradiction, or something along those lines. Anyway, you don't have P, you have P or P. So the question is, how are you going to prove this? All right, so let's begin by writing the assumption down, which is P or P, okay? Now, since you've just learned negation introduction, you might be tempted to try just negating this entire proposition, in other words, the entire conclusion. In other words, you might be tempted to begin by hypothesizing for negation introduction. It's not the case that if not P, then S. But that's definitely not what you want to do. In this context, as far as the power of our proof procedures so far, this is not going to get you anywhere. So the first thing I need you to understand is that any time you're being asked to derive a conditional, you should always hypothesize the antecedent. Okay? So in this case, hypothesize not P. Now, as you know, when you hypothesize not P for conditional introduction, you are now trying to show S, right? And so now, right, after you explore your assumption and your hypothesis and realize that S is nowhere to be found, it would be tempting to go ahead and hypothesize not S, like this, right? Hypothesis for negation introduction. That would really show that you know what you're doing. However, it's not a good idea here, and the reason is because one of your assumptions is a disjunction. When you hypothesize negation introduction, when you hypothesize not S for negation introduction, you are committing yourself to finding a contradiction, right? But the problem is that finding a contradiction from a disjunction would require you to find the very same contradiction twice, once from hypothesizing P and the other from hypothesizing, well, P again, which of course you don't have to repeat since you've already done it the first time. So what you want to do in cases like this, and what I mean by cases like this, is when you have a proof where at least one of your assumptions is a disjunction, is you want to begin by hypothesizing everything you can for conditional introduction. Okay, so we did that on step 2. We hypothesized not P. This means, as we just said, that your project is to show S. Now, if there's nothing you can do to show S on the basis of having hypothesized not P, don't. And remember, this is only if you have one of your assumptions being a disjunction. Don't immediately hypothesize not S. Rather, realize that you're going to be involved in a disjunction elimination, and so remind yourself that your next task is to show if P then S and if P then S. Now, the only reason I'm saying it this way is because if the disjunction were something else, like P or R, you'd be showing if P then S and then if R then S for disjunction elimination. Now, of course, you don't have to show these twice, but that's just to remind yourself that when you do disjunction elimination, you're always going to be citing two lines, two conditionals, which in this case would actually be the same conditional. Okay. So now what you're going to do is hypothesize P, okay, now this is not for negation introduction, this is again is for conditional introduction, specifically to show this conditional. So you want to show if P then S on the basis of the preceding. Now, this is a pretty funny looking proof because you can see now on lines 2 and 3, you have a contradiction. And so this might trick you into thinking that you could just launch in to closing off this proof using the negation introduction rule, but you haven't created a hypothesis for negation introduction yet. You've just got two conditional introduction hypotheses, okay? So the next step is going to be to do what you had an inclination to do before, to hypothesize not S, so yet a third indentation, hypothesis for negation introduction. And now, of course, having hypothesized negation introduction, you are now in the market for a contradiction. Well, that contradiction is just right there above you, okay? So you can just simply write P and not P by 2-3 conjunction introduction. Now again, this is an important thing to notice too, because this just feels weird. When you do negation introduction, you generally find yourself wanting to have the feeling that hypothesizing the opposite, the negation of what you're trying to prove, should somehow create the contradiction that you're looking for, that somehow not S needs to participate in the creation of that contradiction. But that's not true either, okay? Any contradiction works, and it just so happened that P and not P were sitting there for you. Okay, so the important thing here is you really just got to trust your rules and to resist some of your normally trustworthy instincts in proofs like this. Okay, so we now have our contradiction, and it's on the basis of a negation introduction hypothesis. So now we're entitled to infer the negation of the hypothesis. So 6 not S by 4 through 5 negation introduction. Now that's should feel familiar, right? And then, of course, you're just going to go to S through 6 and negation, elimination. And then you have what you were trying to get before, which is if P then S. We're removing our second hypothesis now. Remember, we have to do this in reverse order. So that's 3 through 7, conditional introduction. So take a breath. What have you done? You've just shown if P then S, which you were trying to do for OR elimination, for disjunction elimination, right? So now you need to show your second if P then S, but of course that exists right here. You don't need to do this twice. So now you actually are in a position to assert what you're trying to show initially, which is just F. And you get to assert this through disjunction elimination. Notice this didn't involve the removal of the third hypothesis. This is just what we were trying to get. We were trying to get at. And we've just got it using our disjunction. So we cite the original disjunction, 1, and then the conditional, and then the conditional again, which is perfectly in accord with the rules, 1, 8, 8, disjunction elimination. Okay? And then on line 10, we finally get to assert if not P, then S, drop a line, and that's just by 2 through 9 conditional introduction. Okay, so what have we learned from this? Let's just review. All right, so the most important thing first is that whenever you have something that you're trying, a conditional conclusion that's in the form of the conditional, begin, right? Begin by hypothesizing the antecedent of the conditional. Let me actually write this a little more clearly. So if the conclusion is a conditional, begin by hypothesizing the antecedent. If the consequent is a conditional, then also hypothesize the antecedent of that. And you want to continue until what is left to prove is not a conditional. So, okay, that part was not illustrated here, so let's just make it clear what I mean by this. If rather than if not P then S, if rather than if not P then S, you are being asked to prove something like if not P then if S then Q, right? You would hypothesize not P, but then since what now you're trying to derive is if S then Q, you would immediately then hypothesize S, okay? And that makes your job Q. So hypothesize everything you can for the purpose of conditional introduction. That's basically the first rule. The next thing you have to remember is to check to see if one of your assumptions or even one of the hypotheses you just made is a disjunction. If so, you're going to want to start by immediately doing disjunction elimination and constructing the conditionals that you may need for that. Don't just move straight into negation introduction. Okay, so check to see whether any of your assumptions or hypotheses are disjunctions. If so, you will probably need to use disjunction elimination. So your project now becomes to construct the conditionals required for disjunction elimination. And that's just what we did in this proof when on line 3 we hypothesized P. Okay, and so only now, and what I mean here is if it does turn out to be true that one of your assumptions is a disjunction, then only now should you open yourself up to the possibility of using negation introduction. So in other words, you may be required to use negation introduction in the context of proving one or the other or both of the conditionals that you need for disjunction elimination. Okay, so given a yes answer to 2, in other words, if it's true that your assumptions or your hypotheses, one or more of which are disjunctions, it may then become useful to use negation introduction in creating the conditionals you need for disjunction elimination. Sometimes you'll need them, sometimes you'll need negation introduction, sometimes you won't, but it's there for you to use. Okay? So this isn't something that's going to apply to every proof. It's specifically proofs where you have a mixture of disjunctions and conditionals. This is the sort of flow chart you want to follow. And if you deviate from it, there are times when you'll be able to prove things that way, but there are other times when you're going to be stymied. Okay? I've actually got this all laid out in a flow chart for this module, so it would be worth your time to study that as well, and also make sure you really study the advice for passing the Module 7 test in addition to this. Okay?